Alright, so this is part 3 of our video walkthrough for Lab 3, hubs, bridges, and switches. And in the first section of the video we did a brief recap of the technology that we're dealing with here. We discussed the hub, the bridge, and the switch. And we discussed how the switch is basically a multi-port bridge. So we built a little scenario here in IT Guru. We've got a small star topology network with 16 workstations. And in one of the scenarios it's connected to a switch, and in the other scenario we have them connected to a hub. We've configured some statistics to be pulled once we run the simulation, and all we need to do is configure the runtime and run the simulation. So go up to simulation and choose well, instead of doing it this way, why don't we click the little picture of the man running from the line. We've got a way to configure our simulation here, and what we want to do is we want to change the duration to 2 and then switch the time unit to minutes. Go ahead and click OK to close that. Then go up to Scenario, then Manage Scenarios. And we'll see that we've got both of our scenarios here. We have uncollected results for each, and oh, it looks like we only managed to change one of our duration times here, so go ahead and change that other one to 2 minutes. We want the simulation duration to be 2 and the time units to be minutes for both scenarios. Change these two options to collect and go ahead and click OK to run each of the scenarios. It'll take a little bit of time for the hub scenario to complete, but we'll find that the switch scenario finishes much faster. And we'll just wait till this gets done real quick. Your simulation time here may vary depending on the processor speed of the computer you're running this on. But as soon as those two scenarios run, go ahead and click close. Now we want to take a look at the results that we got. So go up to results and click compare results. Now the first thing that we want to look at is the traffic source traffic sent option. Go ahead and change this option that says as is and switch it to time average. Cleans up the graph a little bit. And then click show to pop the full graph up. So the first thing that we want to note is that in each of our scenarios we had an equal amount of traffic generated. So that's important to know, because as we interpret the rest of our results we want to be sure that each of our scenarios had an equal amount of traffic flowing across the network, so we know that we have an equal comparison. So we can see here that in traffic sent packets per second each of our scenarios was equal. Let's go ahead and close and delete that panel. Let's move on to traffic sync, traffic received. Check that box and then show that graph. Now we can see here that in the switch network we had higher packets per second received on average than in the hub network. Now if you remember back to the lab guide in our discussion of hubs and versus switches, we know that the hub is just a repeater. It's a dumb device and it has no intelligence to make forwarding decisions. It has no forwarding table. All it does is it takes packets that it receives, or bits that it receives at that point in layer 1, and it just repeats those bits out to its other ports. It's just a repeater, and we can see that that impacts the overall throughput of our network. Now this is due to two reasons. One is that the hub has to share its bandwidth to all the links that are connected to it. It's one collision domain, and that also means that there's a lot of packet loss, because with all that data flowing into the hub it just gets overloaded. It's not made to handle that much traffic all at once, and every time that the hub is receiving bits and retransmitting them, that's just wasted time that could be spent efficiently transferring bits across the network, and it just is not an efficient way to transmit data. So we can see here that the switch is more efficient. It's getting a higher throughput than the hub is. This difference here might seem kind of small, but we're only talking about 16 workstations. If we were to up the amount of connected hubs and up the amount of connected switches, this divide here would increase quite a bit because there would be that many more devices overloading the hubs. Let's go ahead and close that graph, delete the panel, and expand Ethernet and click delay. Click show to expand the graph. Now let's take a look here. In ITGRU, the global statistic for Ethernet delay represents the average delay across all nodes across the entire network. So we're looking at the average delay of the whole network, and we can see big difference here. The hub has quite a significant amount of delay, even though it sort of averages out at some point and becomes somewhat stable. There's still a lot of delay, and this is because of the lower throughput and the high packet loss that the hub has. We can see that the switch has almost no delay at all. There's virtually no dropped packets with the switch because each one of the interfaces on a switch is a separate collision domain, so we don't have colliding packets at the switch level. There may be some dropped packets from Ethernet devices attempting to transmit at the same time, but the Ethernet technology itself works that out. We're talking about dropped packets at the switch level, and in this test we don't have any. There's no delay here for the switch. So we can see that the switch is a much more efficient means of transferring the data. Let's go ahead and close this pane, delete it, and there's one more thing that we want to look at. Go ahead and close the statistics window out. We're already in the scenario that has the hub in it, but if you weren't, go to Scenario, switch to Scenario, and switch back to Hub. Right click the hub and click View Results. Expand Ethernet and check collision count. Switch as is to time average and click Show. Now we know that there's no collisions happening on the switch because it has multiple collision domains. We can see here a significant amount of collisions happening in the hub, and that's simply due to the fact that the hub is just being overwhelmed with traffic. There's too much data coming into the hub all at once. It's not able to handle it. Packets are hitting it at the same time, and there's just packet loss. If we were to go into the log file for our scenario, which I will attempt to open right now, if I can find it here. We can see in the log file for our hub scenario, there's lots and lots and lots of dropped packets. And this is just because the hub is being overwhelmed with traffic. And basically that's the end of the lab. So hopefully through viewing the scenario you kind of have an idea of why hubs are not an efficient way to connect LANs and why they've pretty much become obsolete. You know, one of the original reasons why hubs were popular is because they cost a lot less than switches back in the day, but that's largely not true anymore. Switches are pretty cheap, and even your most basic home router has a switch built into it, 4 or 5 ports. And so there's almost no reason to use a hub anymore in a network. There are a couple of sort of specialty reasons. Maybe you have a packet sniffer that needs to be able to access all the data on a LAN, and a hub would be good for that because it rebroadcasts packets on all of its ports. And you may have some type of a network sensor that has to be able to access all of the bits in a LAN, and a hub is also good for that for the same reason. But even then, there are switches available that have something called port mirroring that allows you to do those functions even with a switch. So at this point in modern technology, the hub is largely obsolete. Switches are pretty much the way to go. But it's important to understand how hubs work because it lets us discuss the concept of the broadcast domain and the collision domain. And there are 2 important principles to understand as a budding networking student. So I hope that lab helped you understand network interconnection devices, and thanks for watching.